people constantly wonder, how is it possible for an airplane to fly? How could something that is considered too heavy fly? Well, this is thanks to something called aerodynamic forces and the difference in pressure. The aerodynamic forces are needed for a plane to fly. Because of this, it's very important to know the specifics of how each of them affect the plane and what can be done to manipulate them in a manner that will allow the aircraft to take flight. In order for the flight to occur, we must understand Newton's third law. Every action has its equal opposite reaction, and how it relates to the forces. It could be argued that the lift is the opposite reaction to the weight, and the thrust is meant to counter the drag. Lift and thrust must surpass weight and drag. In this practice, we have taken a scaled model of a Boeing 747-400 and placed it inside a wind tunnel. For the plane model to be situated inside of the tunnel, we set it on top of a wooden stick that will allow us to switch the angle of attack. We analyze the aircraft's reactions when subjected to an airspeed of 75% of its maximum capability, that is to say, around 26 meters per second. This speed was used for every angle from minus 35 degrees to 35 degrees, jumping in an interval of 5 degrees each. A software known as Equipment VDAS was used to connect the laptop to the wind tunnel's panel, where the reactions were being shown. This software was able to take data samples of the reactions. However, it's important to remember to wait until the reactions settle properly, that is to say, until they stop fluctuating. Since the samples consisted of numerous readings, the average of each angle was calculated in order to graph the resulting forces. From the resulting data, the lift and drag coefficients were calculated. Lift can be changed once the angle of attack changes. This was shown within the graphs generated by both the lift and drag coefficients. However, once the plane reaches a certain inclination, the angle will become detrimental, and instead of providing more lift, it will create a greater amount of drag. This is the reason that modern airplanes have flaps that can be moved through the flight. This will change the lift coefficient of the airfoil, thus aiding in the general lift force that is taking action onto the aircraft. The model used for this analysis, the Boeing 747-400, is a very large aircraft in real life, considered one of the biggest ones on the market. Because of this, it needs to have a good lift-to-drag ratio, since this indicates if it will have a better fuel economy and climb performance.